our second scenario or example, we're now decreasing our speed while moving away. We have to think about what this does to our graph. Now, some people have a tendency to try to memorize these. I actually find it works better if you think them through and think about what it means. Decreasing speed means that it's still going to be a curve because it's changing its speed, but instead of a curve that gets steeper, I need to now draw a curve that is going to get flatter as it goes along, which means it needs to start off nice and steep, and as it goes up, it flattens out. Now it still goes up because I am starting at a distance of 0 or close to 0, and it's moving up because I'm moving away from the reference. I'm getting farther from the 0 as I go along. So that makes a big difference. So the slope should get flatter, and it should start off near the T-line, down at the bottom, and move away. Now, when we get to our velocity time graph, just like the last one, I'm still going to have a straight diagonal line because I'm still talking about a constant acceleration. But in this case, I am thinking about a constant acceleration that is getting slower, right? So that means in order for it to be slower, I need to start off, instead of down here with a low velocity, I'm going to start off up here with a high velocity, a big number, and it's going to get closer and closer to 0 because it's slowing down. So my velocity is getting smaller as it goes away. So it starts off away from the T-line up here at a high velocity, at a large speed, and gets closer to a 0 velocity. It's still in the positive quadrant, right? It's still up here in the positive part above the T because it's moving away. And remember, we said anytime we're moving away, we're going to be above the line. We talked about that yesterday when we talked about uniform motion. Now, the last one is the acceleration time graph. This is going to be a flat line again, right? It's going to be a line that is horizontal. But now when I look at the VT, remember I said the velocity time graph will always show you what the acceleration does. In this case, we now have a downward slope, which means we have a negative acceleration. Now that's really logical because we're taking speed away. And to do that, we need our acceleration to be a negative number. So we have a constant value, but negative, since the slope of the VT is negative and we're taking speed away while moving in a positive direction.